Hi, and welcome to this section, Dimension Reduction. In this section, we will first discuss how to perform feature ranking and selection. Next, we will focus on the topic of feature extraction and cover videos in performing dimension reduction with both linear and non-linear methods. For linear methods, we will introduce how to perform PCA, determine the number of principal components, and its visualization. We then move on to MDS and SVD. Furthermore, we will introduce the application of SVD to compress images. For non-linear methods, we will introduce how to perform dimension reduction with isomap and LLE. Now we move on to the first video of this section that shows how to perform feature selection with FSelector. In this video, we will first install and load the package FSelector, and then make an evaluator to select the feature subsets. After this, we will find the optimum feature subset using a hill climbing search. Most datasheets contain features such as attributes or variables that are highly redundant. In order to remove irrelevant and redundant data to reduce the computational cost and avoid overfitting, you can reduce the features into a smaller subset without a significant loss of information. The mathematical procedure of reducing features is known as dimension reduction. The objective of feature selection is to select a set of relevant features to construct the model. The techniques for feature selection can be categorized into feature ranking and feature selection. Feature ranking ranks features with a certain criteria and then selects features that are above a defined threshold. On the other hand, feature selection searches the optimal subset from a space of feature subsets. In feature extraction, the problem can be categorized as a linear or non-linear. The linear method searches an affine space that best explains the variation of data distribution. In contrast, the non-linear method is a better option for data that is distributed on a highly non-linear curved surface. Here, we list some common linear and non-linear methods. So let's have a look at some common linear methods. The first one is PCA. It maps data to lower dimension so that variance of the data in low dimension representation is maximized. Next is MDS, which is a method that allows you to visualize how near, i.e. pattern proximities objects are to each other, and can produce a representation of your data with lower dimension space. PCA can be regarded as the simplest form of MDS if the distance measurement used in MDS equals the covariance of data. Then comes SVD, which removes redundant features that are linear correlated from the perspective of linear algebra. PCA can also be regarded as a specific case of SVD, whereas the examples of common non-linear methods are isomap and LLE. Isomap can be viewed as an extension of MDS, which uses the distance metric of geodesic distances. In this method, geodesic distance is computed by graphing the shortest path distances. LLE performs local PCA and global eigen decomposition. LLE is a local approach, which involves selecting features for each category of the class feature. In contrast, isomap is a global approach, which involves selecting features for all features. Let's now perform feature selection with FSelector. The FSelector package provides two approaches to select the most influential features from the original feature set. Firstly, rank features by some criteria and select the ones that are above a defined threshold. Secondly, search for optimum feature subsets from a space of feature subsets. So here, we will introduce how to perform feature selection with the FSelector package. In this video, we will continue to use the telecom churn dataset as the input data source to train the support vector machine. If you have not prepared the dataset, please refer to Section 5, Classification Tree, Lazy and Probabilistic for detailed information. Let's perform feature selection on a churn dataset. So we first install and load the package, FSelector. So you need to wait a bit while the FSelector package is being installed. Then we use random.forest.importance to calculate the weight for each attribute, where we set the importance type to 1. Here we use the random forest algorithm with the mean decrease in accuracy where importance.type equals 1 as the important measurements to gain the weights of each attribute. Besides the random forest algorithm, you can select other feature ranking algorithms, for example, chi-squared, information.gain, from the FSelector package. So let's run this code. Here you can see the output. Next, we use the cutoff function to obtain the attributes of the top 5 weights. Let's run this code too. In this case, number of customer service calls, international plan, total day charge, total day minutes, and total international calls are the 5 most important features. After this, we make an evaluator to select the feature subsets. First, we need to make a 5-fold cross-validation function to evaluate the importance of feature subsets. Finally, we can find the optimum feature subset using a hill-climbing search. Here we use the hill-climbing searching algorithm to find the optimum feature subsets from the original feature sets. Besides the hill-climbing method, one can select other feature selection algorithms, i.e. forward.search from the FSelector package. Once you run this code, you can see that the international plan plus voicemail plan plus number of email messages plus total day minutes plus total day calls plus total eve minutes plus total eve charge plus total international minutes plus total international calls plus total international charge plus number customer service calls are optimum feature subsets. You can also use the caret package to perform feature selection. As we have discussed in related videos in the Model Assessment section, you can refer to Section 7, Model Evaluation, for more detailed information. For both feature ranking and optimum feature selection, you can explore the package FSelector for more related functions in the Help tab. Cool! In this video, we performed feature selection with FSelector.